Alrighty, hi again. I'm going to be talking about some of the latest changes coming to the new API. Um, Not even sure where to start on this one. I spent a significant amount of time going through curves, basically mathematically proving that the curves we already have are basically sufficient for what we need, more or less. Um, we did implement some new curve types in the API, and it's a complex subject. So, like I say, it's kind of hard to just say, let's start talking about it. We're going to kind of basically just start with what we've got. We've implemented several new curve types. Um, Not sure where to start, really. Let's see. Okay, we have a Bezier, a cubic Bezier, um, a Bezier that is, I think quadratic would be the correct term. Let's see, then a typical, just a standard cubic curve. Catmull for Catmull ROM, which is what we already have in Howler. If you use the curve tool, you'll get a Catmull ROM curve. Cardinal is basically, well, basically the Catmull ROM is a specialized form of the cardinal curve. You can see the formulas look fairly simple. The only difference with Catmull ROM is that the blending function is set to 0.5, or the multiplier for the curve tension is 0.5, whereas the cardinal curve gives you control over the tension at the knots or the data points. There's the Hermite curve, which is basically like a cubic curve with a single control handle, and we also have another implementation of that, as well as yeah, that looks like about it. I think there's a couple more in there, but I'm not sure what I've done with them. Let me take a look at the program here. As you can see, we've implemented a Bezier, which is a curve using 4 data points. The data points basically represents the start and destination of the curve and control handles for the curve. So this is one segment of the curve. There might be many segments joined together at the ends, but this is one segment. And these two lines here are the control handles, and they control the overall shape of the curve, which I think is intuitive if you look at it. You can see the start handle uh, gives an indication of that starting ballistic motion there. And as it comes to a close, you can see it curve into the second control handle. And also the length of the control handle controls the shape of the curve as well. There's also a Hermite curve. I'm sorry, that was a Hermite curve. Okay, that's a Hermite curve. This is a Bezier curve. Same difference here. All right, so let's see. The Bezier curve has different uh, way that the curve is interpolated. So those are two different types of curves that are pretty much similar. Catmull ROM is what we have currently. The limitation of Catmull ROM is that the curves actually don't look that good, even though there's some good qualities about the Catmull ROM. For one thing, the curve always passes through the data point. That's one of the most appealing things. And also the curve goes all the way from the start data point all the way to the finished, the final data point without any break or any stopping. If you used a cubic curve, you would get a smoother, better looking curve. In Lightwave, in Howler, when you use the curve tool and switch to cubic, you get a better looking curve. But one of the limitations is um, the curve doesn't go through the data points. You see a cage around them, and you can see the curves do not pass through the data points. And you also I wonder if I can show this. Let's see. Okay, that's a Catmull ROM. And B-spline, this is a cubic curve. As you can see, the curve does not start at the data point. It starts a little ways past there, and it finishes a little bit before it gets to the final data point. And you can see the curves do not pass through the data points. All right, so that's one of the limitations. Even though it produces a nice looking curve, that's one of the limitations. Lightwave actually has a good shows off curves pretty well. Several different curve types. This is their default is what's called a TCB curve, which is a modified, similar to a Catmull-Rom. I think it's called what's really called a. I had it here a minute ago. Let's see. Well, I guess I lost it. All right. Well, unless there's another page now. Okay. That's it. The Kokenek-Bartels spline is what Lightwave uses, basically, which is a sort of a modified, what they call a cubic Hermite spline with tension, bias, and continuity. We already said that a Catmull-Rom spline is a modified Catmull-Rom. Catmull-Rom is a modified Hermite curve with a set tension. Well, this is a same idea, but with a tension that you can modify, plus bias and continuity. And tension basically controls the shape of that curve, how taut it is at the data points. Continuity sort of gives it sort of a easy, not even sure what to call that. And bias kind of makes it lopsided to one side or the other. So that's Lightwave's default. Then there's a Hermite curve, as we said. You have sort of a handle. Let's see. You have sort of a handle that, for some reason I can't access this. There it goes. You have a handle that sort of controls the in and out points. And there's the Bezier spline. The Bezier spline also has the length of the handle, and it also has it gives it a different quality of curve. So basically, you can see how the handles change the curve without changing the actual data points. So, like I said, we've gone through all this basically to prove how our how our curves in Howler work, that they're adequate for what we're doing, and to implement some new types as well. One of the reasons for doing this was to make sure our keyframing class was working appropriately, because I was considering writing another keyframing class, but it ended up not being necessary, so we basically just took that class and just did a little touch up on it, and it's now part of our API. We're kind of wrapping it into this API so we can take it back into Howler later. But we've got a new gradient class, a gradient stop class that uses the keyframer class. And in the next video, I'll go ahead and discuss that. Okay, so signing off for now.